Welcome back to the Deep Dive, where we cut through the noise on the biggest shifts in tech and give you the essential knowledge you need to stay ahead.
And today, we're tackling a big one.
Oh, it's huge. We're talking about maybe the most critical shift happening in product management right now. We're all moving beyond this world of predictable software.
Right.
We're moving into a world where the system itself learns, it adapts, and it's completely redefining what a product manager even does.
It is a massive transition.
Yeah.
And it all starts with this core realization. For decades, traditional PMs, we all operated on what we call deterministic systems.
Right. Determinist.
Think of it like a perfect machine. You wrote the rules, if this, then that, engineers coded it, and the system did exactly what you told it to do every single time.
It was predictable, a clear binary relationship.
Exactly. And success was simple. Did the code execute the logic we wrote down? Yes or no?
That clarity, that comfort zone is just dissolving now.
Yeah.
And fast. The AI era just flips the whole script. Now we're dealing with, as you say, probabilistic systems. And this is really the core of the challenge we need to unpack. What does that actually mean for the person building the product day to day?
It means the source of truth has moved. The core logic of your product isn't explicitly coded anymore. It's learned from massive amounts of data. So the models, they make predictions, they make suggestions, but they never, ever offer a guarantee.
So the output is always variable by its very nature.
Always. It changes based on the context, the input data, the model's training, even how good the user's prompt is. And this is the key part. Performance is emergent.
Emergent. Okay, what do we mean by that?
It can get way better as it sees more data, but, and this is the scary part, it can also get subtly worse over time without a single line of code changing.
Just because the real-world data starts to shift.
Exactly. That's what we call data drift.
So that is the fundamental difference then. If the system's behavior isn't predefined in a spec doc, if it's constantly fluctuating, the PM's job can't be about managing a feature checklist anymore.
It can't. You're not just managing scope and timelines. The focus shifts entirely to the things that govern that emergent behavior.
Okay.
And this is why an AI product manager is a different role. You have to master data quality, you have to define the training inputs, build feedback loops, set safety standards that go way beyond old school QA.
And build these continuous evaluation frameworks.
You have to, which is why we say it's so much more powerful. The potential is incredible, but it's also infinitely more complex because you're managing uncertainty.
So that's our mission for this deep dive. We're going to explore all of these unique considerations, and we're going to use frameworks from some of the pioneers in the space, like Intercom. We want to give you the tools not just to understand this shift, but to actually build within it, to manage that uncertainty and, well, make the probabilistic predictable enough to be useful.
Okay, let's unpack this mindset shift. If you're a PM, say, from a traditional SaaS background, you're used to defining success by, what, feature completeness?
Right, or velocity. How fast is the team shipping? Did we build exactly what was in the product requirements doc?
In that world, the deterministic world, the logic is the feature. It either works or it throws an error. It's a binary.
Yeah.
In the AI world, that safety net is gone. The logic is learned, the behavior is probabilistic, and so the PM's focus has to shift away from just delivery. It becomes more about stewardship.
Stewardship, I like that. You're not just a project manager, you're more like a curator of this living thing.
That's a great way to put it.
So when you say stewardship, what does that actually look like day to day? I imagine it's not just managing the code, it's the data, the assumptions.
All of it. And you have to obsess over things you never thought about before. A traditional PM worries about, APIs and a slick UI. An AI PM have to, first and foremost, obsess over data quality.
Garbage in, garbage out.
It's worse than that. Garbage in means biased, unsafe, or just harmful outputs that can destroy your brand's trust. So you define the training inputs, you build robust feedback loops, because the model is only ever as good as the data you feed it.
And you mentioned this idea of performance never being static. In the old world, you fix a bug, it stays fixed.
Right.
Right.
Until an engineer breaks it again. But here, performance is always in flux.
It's this continuous cycle of improvement and degradation.
We call it model decay or data drift. Let's say you launch an amazing AI that classifies support tickets. Perfect. 6 months later, your company launches a new product. The kind of complaints people have changes completely.
And the model has never seen that new language.
Exactly. So its performance silently starts to slide, even though the code is untouched. That's why you need constant, rigorous model monitoring. You have to treat it like a living system.
And what does that monitoring involve? It's more than just checking if the server is up, I assume.
Oh, much more. You're looking for anomalies in the input data. You're watching the output entropies, the model getting stuck in weird loops. And most importantly, you're detecting that data drift. You have tools that analyze the stats of the live data and compare it to the training data. If they diverge too much, an alarm goes off. And the PM is the one who has to define what too much means for the business.
Which leads right into the next piece. Evaluation. If the system is unpredictable, how do you even measure if it's working?
Yeah, you need totally new evaluation frameworks. Simple pass-fail tests don't work for probabilistic behavior. You can't just check if the button works.
You have to check if the output is useful and safe and relevant.
Across millions of possible inputs. So we need new metrics. Things like relevance, confidence calibration, and the big one, hallucination rate.
The percentage of time the model just confidently makes stuff up.
Exactly. And the AI PM is responsible for defining those metrics with the data scientists and making sure the teams are hitting them, because that's what translates to user trust in the real world.
So it seems like a traditional PM manages technical risk, but an AI PM manages systemic and operational risk.
That's the perfect distinction. The role now includes safety, bias, privacy, ethics, right at the core of the product strategy. It's not an afterthought for the legal team anymore.
Okay, to make this more concrete, let's dive into the framework from Intercom. They were really on the front lines of this stuff, and these Intercom 5 are basically the core mandates for building AI products.
Yeah, and these aren't just tips. They are fundamental shifts in strategy. It's about moving the conversation from how do we use this new tech to how does our entire organization have to change?
Right. So takeaway number 1 is AI is a platform shift, not a feature. This analogy is so powerful. When the internet came along, you didn't just add a web link feature to your desktop software.
You built a website. When mobile came, you didn't just shrink the website.
You built an app, it used the camera, GPS, it was a new platform.
And AI is the fourth one. After the internet, mobile, and the cloud. The source material is really clear on this. If you treat AI as just another feature, like adding a summarize button, you are missing the entire point.
You're just optimizing the old way of doing things instead of inventing the new way.
Exactly. You risk getting completely outpaced.
Can you give us a concrete example? What's the difference between a feature mindset and a platform mindset here?
Sure. Think about a classic customer support tool. A feature approach is, let's add an AI button that summarizes the last few messages. Okay, that's helpful. It's an increment.
But it's not a transformation.
No. A platform approach rethinks the entire workflow. Instead of an agent opening a ticket, reading the history, searching the knowledge base, then writing a reply.
Right, all those manual steps.
The AI platform is designed to do all of it. Triage the ticket, synthesize the history, find the issue, draft a personalized reply, and maybe even execute the fix, like issuing a refund, all before a human even sees it.
So the PM is managing that whole automated chain, not just the little summarizer tool.
Exactly. You're thinking about how AI can cut 10 steps down to 1.
Okay, that brings us to takeaway number 2. You must move quickly. Speed is a competitive advantage.
And this isn't the usual move fast and break things. The pace of change here is just, it's on another level. New models, new tools are coming out weekly.
So if a much better model from OpenAI or Anthropic drops next month and you're still tied to your old architecture?
You're suddenly a legacy product.
Yeah.
Your competitors will leapfrog you. We're in this arms race where the fundamental building blocks are shifting under our feet.
So how do you manage that? It's not just about deploying code faster. It's about organizational agility, right? But how do you balance that speed with the trust and safety we just talked about?
That is the tightrope the AI PM walks.
Yeah.
Speed means you have to do lean experiments, rapid prototypes. It means you have to be willing to launch what the source calls a version 0.
A version 0, so something that's functional and safe, but imperfect.
Exactly. You don't launch it to make money. You launch it to get real-world data and feedback that you cannot simulate in the lab. You're trading perfection for speed of learning.
And the safety part.
The safety comes from the design. You launch version 0 as assistive, not autonomous. You put a human in the loop for anything risky. So you can learn fast, but the consequences of a mistake are contained. If you wait for 99.9% accuracy, you've already lost.
This feeds directly into the third takeaway. Users expect magic. You have to build for the outcome, not for feature completeness.
This is all about the cognitive shift that systems like ChatGPT have created. Users now have a new baseline expectation.
They don't want a toolbox anymore.
No, They don't want a hammer and nails. They want an assistant who builds the porch for them.
That's a great way to put it. A tool needs you to know all the steps. An assistant just needs to know the goal.
Precisely. So the AI PM isn't focused on Olympus features like advanced text editing. They're focused on the outcome. Did we solve the customer's issue in 5 seconds? Users expect to just speak in natural language and have the system do the thing. Do it for me.
So back to the support ticket example. If the system drafts a reply that's 90% right, the user doesn't care about the 20 editing features you built.
They just care that the draft is good enough to quickly approve and send. Your job shifts from building out a feature set to maximizing the delivery of that delightful automated outcome.
Which brings us to takeaway 4, and this is a big one. Trust, reliability, and safety are as important as capabilities. If the system can do magic, it can also fail in some truly new and scary ways. Hallucinations, bias, unsafe answers.
And users will not use AI for anything important if they don't trust the output. Think about an AI legal assistant. If it makes up a case law citation, that's not a bug, that's malpractice.
So earning that trust has to be designed in from the very beginning.
Absolutely. The source material lists several critical things you have to implement.
We mentioned disclaimer, sure, but what about the actual guardrails? How do you enforce safety?
Disclaimers are the bare minimum. To enforce safety, you need multiple layers of guardrails. These are often smaller, rule-based models or specific prompts designed just for moderation.
Like a filter on the way in and on the way out?
Exactly. An input guardrail checks the user's prompt for malicious stuff. An output guardrail checks the model's response for factual errors or unsafe language before it ever reaches the user. You also need safe defaults.
Meaning?
If the model is unsure, it has to default to deferring to a human or using a safe pre-written template. It can't just guess.
And that human-in-the-loop design is key to building trust over time.
It's mandatory. And transparency. The user needs to know why a decision was made. You have to show your work, provide the sources a confidence score, something to help them trust the output.
Okay, that leads to the final takeaway, number 5. You need continuous improvement. AI products evolve.
This really hammers home that AI products are never done. The old life cycle of build, ship, maintain, it's just obsolete.
It's dead.
It's replaced by a continuous learning loop, and it has to be a circle. Build, train, evaluate, ship, collect data, retrain, improve, and then do it all over again.
The AI PM's main job, then, is to make sure that loop is flowing efficiently.
And that it doesn't break. If you stop collecting good feedback data or the retraining process stalls, your product doesn't just stagnate. Because of data drift, it actively gets worse.
It decays.
It decays. So you have to be constantly feeding it better inputs, better models, better fine-tuning data, better prompts, and especially that real-world user feedback to drive reinforcement learning. The PM has to manage that entire pipeline.
Okay, so we have the philosophy, the Intercom 5. Let's get practical. As an AI PM, how do you even know if AI is the right tool for a given job?
That's a core skill. You can't just throw an LLM at every problem. You have to know the boundaries of the technology, where it excels, and where it's just going to introduce unacceptable risk.
So let's talk strengths first. Where does AI really shine?
It's incredibly good at high-volume cognitive tasks that, frankly, bore or overwhelm people. So pattern recognition in huge data sets, language generation, summarization, creative brainstorming, any predictive task based on history, like classification or anomaly detection.
Basically automating repetitive cognitive work.
Exactly. If a task involves quickly making sense of a mountain of unstructured data, AI is probably a good fit.
All right, now the flip side, the weaknesses. This is where the PM has to draw the hard lines.
These are the no-go zones. AI, especially LLMs, is really bad at pure, new deductive reasoning without any data to go on. It can't innovate in a vacuum. It struggles with high-precision deterministic tasks where the answer has to be perfect.
Like complex math.
Or detailed legal contract analysis. It's a prediction engine, not a calculator or a lawyer. It also has no real common sense, no understanding of the physical world, and it can't handle decisions that need deep emotional or ethical nuance.
And the big one, real-time, safety-critical decisions.
That is the highest risk area. Anything where a failure could cause catastrophic harm controlling medical equipment, air traffic control, that's not a place for autonomous AI right now. The PM has to know that boundary, Cole.
So taking all that, we can start building a checklist. What makes a problem a really good fit for AI?
The best opportunities are usually at the intersection of complexity, high volume, and high human cognitive load. Think triaging thousands of support tickets, or summarizing long customer call transcripts to save an agent 15 minutes of reading time.
And it's great at handling messy, real-world data.
For sure. Unstructured data processing is a one analyzing call logs, interview transcripts, social media sentiment, predictive tasks like who's going to churn, and, of course, creative ideation. Generating 5 different ad campaigns or A/B testing where variety is more important than perfect accuracy.
And the poor fits are where high risk meets the need for perfect certainty.
Exactly. Anything that demands 100% accuracy, anything heavily regulated where you need an immutable, auditable trail of logic. Using an LLM to automatically fill out a critical tax form where one wrong number could trigger a massive fine.
Probably not a good idea.
You're better off with a deterministic, rule-based system, or at least keeping the AI firmly in that suggestion layer.
This is a perfect point to introduce the practical framework you mentioned, the 4 lenses. This is how a PM can systematically vet any potential AI project.
Right. And you need alignment across all 4 lenses. If one is out of alignment, the project is likely to fail.
So, lens number 1 is user workflows, the pain point.
This is classic PM work, but you're looking for a specific kind of friction. Repetition, manual data synthesis, decision fatigue from information overload. Where are your users just getting bogged down by cognitive strain?
So you find the pain. Then you need to see if you can even build a solution, which I guess is lens 2.
Lens 2, data availability, the fuel. This is where so many projects die. Do we have enough relevant, high-quality, clean data to train a model or even prompt an LLM effectively? And can we afford to acquire and label it?
The hidden cost of AI.
Oh, it's huge. And can you collect ongoing feedback signals once it's live to keep the improvement loop going? If you don't have the fuel, the car isn't going anywhere.
Okay. Lens 3 is the tech itself.
Lens 3, AI capabilities. You have to ask, with your ML team, are the current models actually good enough for this specific problem? Do we need a big, expensive LLM, or could a smaller, faster, cheaper, specialized model do the job? Or maybe we don't even need AI. Maybe some clever rules would work.
So you have to balance the capability with cost and speed.
Exactly. If the best model is still only 70% accurate, but you need 95%, then the tech just isn't ready for that use case yet.
And finally, the safety check, the most critical lens.
Lens 4, risk and impact. This forces you to ask the scary question, what is the specific harm if the model is catastrophically wrong just one time?
And you have to quantify that harm, low, medium, high.
Catastrophic. Is it a minor spelling error or is it bad medical advice? You have to define the acceptable harm threshold for the business. And maybe most importantly, will your users actually trust AI in this workflow?
If the harm is high and the trust is low, it's a non-starter, even if the other 3 lenses look good.
And when all 4 pain, fuel, tech, and safety align, then you've got a validated high-potential AI opportunity. Then you have a green light. It's a disciplined filtering process that separates the good ideas from the dangerous ones.
So once you've identified an opportunity, you have to actually design the feature. And because of that probabilistic nature, the design principles have to be different.
Yeah, design becomes your first line of defense against uncertainty and failure.
Which brings us back to something we talked about with the Intercom 5. Start with outcomes, not features.
It's the essential starting point. You have to define success in business terms, not in model accuracy scores from a lab.
So instead of saying, let's add an AI summarizer,
You say, let's reduce support ticket handle time by 40%, or increase new campaign creation by 3x. It's measurable, it's aligned to the business, and it gives the engineering team a clear target.
the outcome defines the requirements.
Exactly. Your key performance indicators become things like time saved per task or human editing rate, not just abstract scores. That bridges the gap between the ML lab and business value.
Okay, another key principle you mentioned is make AI assistive, not autonomous, at least not at first.
Trust is earned. You don't hand over the keys to the car on day one. You start with systems that assist the user, let them validate the AI's confidence, and then you gradually grant it more control.
Can you walk us through those stages? This seems like a really important roadmap for launching an AI feature safely.
Sure. It starts at stage one. AI suggests. The AI offers a draft or a classification. The user is 100% in control of reviewing and accepting it. This is the learning phase.
Okay.
Then, once you've proven some basic utility, you move to stage two. User approves, a bit less friction. The user just has to confirm the suggestion.
So the user's still in the driver's seat. What's next?
As trust builds, you can move to stage three. AI executes, but the user oversees. For medium-risk tasks, the AI takes the action, but the user has a clear, immediate way to undo or correct it.
And the final stage.
Stage 4, automation becomes trusted. For low-risk, high-reliability tasks, the AI just acts autonomously. It only bothers the user if it runs into something exceptional or high risk. This whole phased approach is how you manage probabilistic risk in the real world.
It also seems crucial to build for explainability. If the user doesn't know why the AI did something, they won't trust it.
Right. Transparency is the engine of trust. Users need to understand, at some level, why the AI came to a conclusion, what data it used, and how they can override it.
What does good transparency look like in a product?
So instead of just showing a generated reply, the UI might also show little links to the specific knowledge base articles the AI used to write it. Or if it's an image model, it could highlight the parts of the image that led to the classification.
Giving the user context.
And a confidence score. I'm 95% confident in this answer. That tells the user when they should probably double-check the work.
We know AI will fail, so the next principle must be have a safe failure mode.
Yes. The system has to fail gracefully. When the model's confidence drops below a certain threshold, it has to recognize that and default to a safe state.
What does a safe state look like?
It could be a few things. 1, immediately escalate to a human. 2, offer a safe, pre-written, generic template instead of guessing. Or 3, just revert to the previous state. The point is, the user needs a clear fallback, and the workflow can't break.
And to make the whole system better over time, you have to establish and utilize feedback loops.
This is the engine of that continuous learning loop we talked about. You have to build explicit feedback mechanisms right into the UI.
The classic thumbs up, thumbs down.
That's the start, but you need to go deeper. You need to capture user corrections. If an agent edits an AI-generated reply, that edited version is pure gold. You capture the before and after.
Because that's the data that teaches the model what good actually looks like.
That's the data that fuels reinforcement learning from human feedback, or RLHF. It's how you fine-tune the model based on real human preference. This is an optional feature. It's a core product requirement.
And finally, a point we've touched on a few times, evaluation frameworks require new metrics.
Right. Traditional accuracy is not enough. You still track it, but you have to add metrics that are unique to AI failure modes.
Like the hallucination rate, how often it's just making things up.
That's number 1. You also have to track latency slow, AI is bad AI, and confidence calibration.
Remind us what that is again.
It's making sure the model's self-reported confidence actually matches its real-world accuracy. You don't want a model that's wrong half the time but says it's 99% confident. That's dangerous.
And you have to tie all these technical metrics back to the business.
Always. You track user satisfaction, task completion time, deflection rates, and you need to be doing both offline evaluation on clean data sets and online A/B testing in the real world to prove the AI is actually better than the old way.
Okay, so the AIPM has a new philosophy, new design principles, new metrics. How do they actually operate within the company? The team structure must change.
It changes completely. The AIPM has to bridge disciplines that used to be totally separate. You're not just working with software engineers anymore. Now you're in deep with ML researchers, data scientists, data ops.
And you have to speak their language, at least a little bit. You have to be technically fluent enough to ask the right questions.
You do. Your focus expands to things like data sourcing, defining retraining cycles, evaluating model performance. It's a much heavier technical lift than traditional product management.
And the requirements you write have to be incredibly precise.
Meticulously clear. You can't just say the summary must be accurate. You have to say the model must achieve a ruse score of 0.45, maintain a latency under 500 milliseconds, and have a hallucination rate below 2%. You also have to create things like a model cards documentation that explains a model's limits and known biases.
This brings us to the heaviest new responsibility: ethical, privacy, and risk considerations.
This is where the PM becomes a proactive safety designer. You have to manage several new risk categories. First, data privacy. If you're using customer data for training, how are you anonymizing it? Are you compliant with GDPR? If you're sending data to a third-party API like OpenAI, what are their data retention policies?
That's a huge new vendor management challenge.
It is. And then there are the security risks that are unique to AI.
Like prompt injection.
Exactly. When a user tricks the model into ignoring its instructions and doing something malicious, the PM has to work on the system architecture to sandbox the model, to isolate it from critical systems, so even if an injection happens, the damage is contained.
So you're building these protective layers into the product from day one.
You have to. Mandatory guardrails, content filters, human oversight. You have to look at every feature through the lens of potential harm.
Let's pull this all together with that idea of the product as a living system. How does that evolution actually happen in practice?
So the evolution happens on a few different tracks that the PM is managing. There are the big fundamental model upgrades when a new, better foundation model comes out, but there's also constant, cheaper tuning.
Like prompt engineering.
Exactly. Prompt tuning is the fastest, cheapest way to improve performance, just refining the internal instructions you give the model before the user's query. The PM defines the quality bar, and prompt engineers are constantly iterating to hit it.
And then there's the evolution driven by user behavior.
Through RLHF. All that feedback data, the edits, the ratings, is used to fine-tune the model, teaching it what users actually want. This is paired with constantly improving your evaluation data sets to make sure your lab tests actually reflect the messy reality of production.
So even the UI is constantly evolving based on the model's performance.
It has to. If monitoring shows the model's confidence on a certain task jumped from 70% to 95%, the PM might update the UI to move that task from AI suggests to automation with review, taking a step out for the user. It's this constant dance between model performance, system safety, and interface design.
This has been an incredibly dense deep dive, but I think the frameworks give us a clear map for navigating this shift from deterministic to probabilistic PM.
Yeah, the source material really boils it down to 5 non-negotiable mandates for any modern AI PM.
Okay, let's recap them. First, you have to recognize AI as a true platform shift. It's about transforming workflows, not just adding features.
Second, you have to deploy rapidly but stay obsessed with refinement. Your competitive edge is your speed of learning, which means embracing that version 0 mindset.
Third, build those outcome-driven experiences. Focus on the user magic, on being an assistant, not just a set of tools.
Fourth, and this might be the most important, prioritize trust, safety, and transparency above everything else. Without it, users will not adopt your product for anything critical.
And finally, you have to build and maintain those continuous learning loops. Your product is a living system. It has to evolve or it will decay.
The modern AI PM role is just this complex hybrid thing. You're part product strategist, part systems thinker, and part data steward. It is without a doubt the most challenging and exciting role in tech right now.
It really is. The pace of change is just incredible.
You know, if the entire job of an AI PM is defined by this shift from static deterministic systems to these living probabilistic ones, it raises a huge question for everyone listening. We talked about how product design has to become dynamic, but most of our organizations still run on very static, deterministic processes. So how do we change our traditional structures, like rigid annual budgets, fixed quarterly roadmaps, to actually support a product that is designed to evolve continuously even after it's launched?
That's a great question.
If your product is always being retrained, what's the organizational limit of version 0 when the entire structure around you is demanding a finalized version 1.0? That's really the next big problem for leadership to solve.
A perfect challenge to leave everyone with. It forces a complete rethink of how we plan and build in this new era. Thank you for joining us for the deep dive. We'll see you next time.